Generative AI is a powerful type of artificial intelligence that can produce various forms of content, solve complex problems, and improve our lives in many ways. It's impacting the world around us, enabling creative teams to produce new art forms, assisting the medical industry in developing new drugs and treatments, creating new investment strategies in the financial sector, and optimizing manufacturing processes. As the technology develops, we'll see even more innovative and transformative applications. We're in the midst of a revolution. But what does revolution mean to Xebia? When texting and other communication apps came to smartphones, that wasn't a revolution. The real revolution came when families adopted this technology, using it to share memories and connect with loved ones near and far. But technology can only be adopted when the infrastructure is there. When engineers turn technical frameworks into solutions that are accessible for end users. That's how Xebia sees a revolution. Harnessing technology to support our people and clients to create a better future for everybody. At Xebia, we're creating our own revolution. People behind every service Xebia provides are working to identify Gen AI goods to enhance our possibilities. Cloud, data, software technology, low-code, it's just the beginning. We believe in talent, not in building businesses on guesses and predictions, and we know it's the people behind the technology who can really create a difference. We're not just part of this revolution. We choose to actively participate in leading it because we believe in data, not in the hype. Xebia, creating digital leaders.
It's all okay now?
Yes.
Yeah? All right. Thanks for tuning in and thanks for staying with us. Today we're going to have a webinar about generative AI. We're going to talk about technology and about specific applications. And for that we have two amazing guests here at the table. We have Rui, product manager at ING, and Caio, who is a Gen AI specialist here at Xebia. Rui, would you like to maybe tell something about yourself?
Sure. First, thank you for this opportunity. It is a pleasure to be here with you and with Caio. So my name is Rui, I'm Portuguese. I work at ING since 2020 as a product owner, as you said. Product owner of a wonderful tool. I really love this tool. Before ING, I worked as a consultant, mainly at Arthur Andersen and Deloitte. But then in other companies like PwC, CapGemini, and other consulting companies, working in many industries, in many countries also, always in the analytics field, in technology, and in a more personal side. I am married, I have one daughter, 2 cats, I love photography, I love running, so I love to run marathons. And I am a Nunchaku athlete. If you don't know,
cool.
the
sticks
like Bruce Lee. So, and I'm glad to be in Amsterdam because, well, Dutch guys are the best in the world in these sports, and I'm learning with the best ones. So, and I love these sports. And in a nutshell, it's what I am.
I never heard of that. That's so cool. I didn't know that the Netherlands had some great Nunchakus.
You should see some videos.
Cool. Thanks. Caio, how about you? Tell us about yourself.
All right. So good morning, everyone. Thanks for this opportunity. So my name is Caio. I come from Brazil. And I have been working with AI and data science, which didn't even have this name at the moment, since 2014. When I started my master's, so I started in academia, worked with medical data in the beginning, went through my PhD. Then I went back to the industry in around 2021. And I joined Xebia this year. And since then, I've been dedicated to what we're going to talk about today, and generative AI and large language models. So yeah, my personal time, I just like barbecuing and traveling. So you usually see me doing this stuff. Yeah,
you just arrived in Amsterdam, so you're also exploring everything that it has to offer.
Oh yeah,
and
definitely.
That's great. And could you maybe tell us a little bit about what types of activities you've already done in the field of Gen AI in your time here?
Okay, so yeah, it's a big umbrella. It's very versatile. So there are lots of applications we've been working on. So since something conversational, which is intuitively everyone thinks about, all the way to something more powerful and robust on dealing with unstructured data, some technical data we need to retrieve information. So yeah.
Cool. And I've seen you speak at conferences about it or at meetups and
at,
making proof of concept. So it's really cool to see you active in that area.
Yeah, my face is maybe familiar here and there because I've been giving some workshops. It's really fun. And especially how people get enthusiastic about it. So it's a really fun topic. Yeah.
Cool. I didn't share it before, but for the people at home, if you have any questions that you would like to share with us here at the table, I can monitor it over here. So if you have a question, I'll try to weave it into the conversation that we're having. Now, thanks, Kayo, also for sharing your experience. And I'd like to just get started with you, Rui, about what are you doing at ING? What product are you working on?
Yeah, so like I said, it is a really wonderful tool. So this tool is called Aria. And what it's for? So this is a tool to help our risk managers and the front office users to manage their portfolio in a daily basis. And we are, so it is supposed to send signals using internal and external data. Okay. So in this case, we have two main components. So the internal side, we use internal systems to retrieve mainly financial information. Okay, and then with this information, we manage it and we create signals, so alerts to our users to be aware of a potential risk in this specific client using this tool. And then we have, I would say, maybe the huge part of this tool that is the external side, where we use the Google Cloud Platform and, well, several Google APIs. And in this case, so we extract information from external third parties, in this case like Google News and other software vendors from where we retrieve financial information, and we do more or less the same as the internal side, but in a different way. But we also manage this information to send signals to the users, and this way they can manage the portfolio. And why we have created this? Because, well, maybe 4 or 5 years ago, ING didn't have any global tool to do this. And we wanted to avoid, because, well, ING is really big, as you may know, so we have employees in all around the world, and we wanted to avoid all the ING countries to create the same tool in all the countries. And so the idea was to create this centralized tool to avoid it. In another way is to have in one single tool all of these external and external information in one single platform. And also because this is, as you may understand, a lot of information, and our risk managers and front office user needs to, in a daily basis, to retrieve a lot of information, financial information, need to read the articles in a daily basis for all our clients to anticipate if there is any potential risk. And so we wanted also to avoid these users the need to collect information from the system A, system B, system C, going to the internet to read all the news. This is a huge work they need to do.
So if I understand you correctly, you have people in ING, your risk managers or account managers, and they have a challenge, which is that to stay up to date on all of their customers.
Exactly.
They have a huge challenge because their customers are also big countries, maybe even all over the world. They have many customers, and they're in many places all over the world. Everything is happening. All these news articles are being published, and you want to stay up to date. You cannot just look that up yourself. So what you want is that these managers get alerts, basically, like, hey, there's something relevant happening about one of your customers. Proactive.
Yeah, exactly
Cool.
that.
Nice. And can you maybe tell us, like, more about why is that so hard? What's driving the complexity here? Because I think the value we can see, but why is it hard?
Yeah. So as I said, this is a huge amount of information, a huge amount of data that we need to deal in a daily basis. And for you to have an idea, so we have in a daily basis, we collect around 300,000 articles a day. that we need to manage. And this is from 54 different languages that we need to translate to English using a Google API to do this. We have in scope, it's more or less 30,000 entities, so 30,000 entities,
companies,
companies, yes, that are in
interested
scope of this
Wow.
project. And specifically from the articles, so we have more than 2,000 different publishers from where we retrieve all the news from all around the world, so from all countries. We have a kind of a white list of publishers for each country from where we retrieve this information from Google News. Okay, and then more specifically about the financial instruments. So in a daily basis, so this is a bit more technical way, but we have around 500,000 calls a day. So using specific APIs to retrieve financial instruments from our clients, like equities, external ratings, and other kind of information. Going a bit and again to the articles, so we have already some machine learning models, so we have already some advanced models, and at this moment we have 15 machine learning models used in this pipeline. So 9 of these machine learning is to filter out the articles that we don't want to have in our database, like for example, a vehicle accident or a product promotion. So that is not so interesting for our users to be aware. And then we have the core. The core are 6 machine learning models, where we try to find inside the articles if the article is about fraud or bankruptcy, always in a negative way. Okay, because if you put yourself in the mind of a risk manager, so the final goal is, I need to find if there is any problem with my clients. So it is always in a negative way. And other topics are, for example, human rights or environment and climate change. So all of these topics always in a negative way. And this pipeline of the articles are really huge. So as you can see in this slide, so we retrieve information from Google News, and first we need to find inside the articles if there are any duplicates, and we need to extract the duplicates ones. Then we need to find entities, so our customers inside the articles. Okay, then we need to translate. Then
Can I interrupt you? So so when you need to find the customers, that's also not always straightforward, right?
No.
Because
No.
it can go wrong. Can you maybe give an example of that?
I can give you two topics, two examples on that. So, but the first is when you think about a client, a customer can be named in many different ways. Okay, and so if you write an article, you can name ING, for example, ING Netherlands, for example. But if it is Caio, it can write, for example, ING Bank. But the entity is exactly the same. And so first, so we need and we use a tool that is DBpedia, that do this mapping between all the names for one entity to a single one. Another example, and this could happen also in this case, that is, if you have an entity that can be confused with another topic, for example, Jaguar. Jaguar is an entity, but it's also an animal. And so in this case, the models can find, okay, is there a Jaguar, so it is an entity, but then we need to understand if this is really a company or if it is the animal. So we need to understand the context of the article, and so this is one of the challenges we also have in here. In this part.
Nice. So then you found the right companies, so you know it's relevant.
And the final of the pipeline. So I already explained. So we have the filter models to filter out the articles, the main topic models, the machine learning models, the 6. We have 6 models, and then by the end, so we have also 2 advanced models, one to aggregate the news, For example, like I said, so we collect around 300,000 articles a day. So as you can imagine, if there is one article about something that happened today or yesterday, if it is rarely known in the world, so it will be a lot of articles about the same subject.
Yeah.
And so we need to aggregate all these articles that are about the same subject, and so we use a clustering algorithm to do this, to don't spam the users with 60 or 100 articles about the same stuff. We don't want that, so we will send just one, and the other ones are, the group are aggregated. And the last step is to give a relevancy score to the articles. And what's this? If you are a risk manager for a specific entity, you would like to see on the top of your list when you search for the articles the most relevant ones. And so we have also an advanced algorithm to sort the articles by the most relevant to the less relevant. And then the users can see on the top, okay, these are the main articles or the first articles I should read about my portfolio of customers. And so this is really a huge pipeline. It is hard to maintain. When we have an issue, we need to understand exactly if it is in the step 1 or step 2 or step 3. So, and sometimes it's not so easy to find where is the problem, because the pipeline is really complex.
All right, so that's also where you're facing some challenges, and where you're maybe hoping to do better with this new technology.
Absolutely.
All right. Great. And maybe for a bit of color, like with how many, what does your team look like? How many people are you working on this? Who's facing this challenge?
Yeah, so we have a team that is split in between Netherlands and Poland.
Yeah.
In Netherlands, so let me count. So so we are 5 here in Netherlands, plus 4 in Poland. And so we have many roles in the team. So I am the product owner. So that we have 2 data scientists that are mainly working in these machine learning models with the Google Cloud Platform. So mainly in this side, we have another person also here in Netherlands. So he is not data scientist, but he is also a statistician. So he understands a lot of statistics, mathematics, and also working with GCP. We have Java developers, mainly in Poland, 1 front-end developer, and 1 ops engineer that helps a lot the team, because so this is really huge. And so we need to have this knowledge to maintain not only the Google Cloud Platform, but all the databases that are installed in there, and also the internal side. And so this person also helps us a lot doing this job. And in this case, we avoid the developers to the need, for example, a specific example, to install a certificate in a server. We have this person that guarantees that everything is stable in the platform.
Cool.
So it is a multicultural team, and we have, so I am Portuguese, we have Dutch people from Turkey, Poland, Italy. So we have a multicultural team.
That's nice, especially also we have all these articles coming in different languages, so you can also it helps maybe a bit with the debugging and everything. Cool. Nice to hear about this challenge. I think now is maybe also a nice time to maybe switch to the other topic of the day. So we now have heard a little bit about that use case, where you see like, hey, I see opportunities here, well, you're facing challenges, and that you're saying like, hey, maybe something in generative AI can help here. But before we maybe dive into what opportunities that you see, we can maybe talk in more general. What are we talking about here when we're talking about generative AI and large language models and those type of things?
Okay, so let's say large language models is a term that falls in this huge umbrella of called generative AI. And I think everyone felt already the power of large language models, but just with a different face, which let me phrase like this, is the thing behind Google Bard or ChatGPT. So the core of it is a large language model. So it's a language model, it's a machine learning model that is trained on, say, a tremendously huge volume of data to an extent that it captures the semantics of language. Language is exactly how we're communicating right now. So it makes what makes it really powerful.
Yeah. So, and when they are trained on this huge amounts of data, like what should I imagine then? What type of data goes into such models?
Text. I don't want to say go through the technical term, but it's called corpus. But with a huge amount of text, materials from the web, for example,
news articles, Wikipedia,
books, Wikipedia. Yeah.
All right, cool. And then, so what's so great about these LLMs?
So when you have a powerful model like this, they can be very versatile. So, for example, as I even mentioned in the beginning, we can have something, let's go to the more intuitive path first, something conversational.
Yeah.
So we have language. So with that, we can do some question answering about some sort of subject. We can have, we can create content, which is, I think it's what make it a very big hype. So to create a script for YouTube videos, for example, or to summarize something, or you're in that meeting that was very long and you get the transcriptions, just throw to it and like, what is the gist of it? What were they talking about? So we can do summarization. We can have something more elegant, say, if we have complex, unstructured data, we could have an elegant way to search for specific information. So the model will have its attention here and there and get the main points you want to retrieve from a large piece of text. Yeah.
Those are already quite complex applications, huh? But I think we're all using these type of chat models also in our daily life sometimes. Maybe Rui, what have you used these chat models for to help you in your daily life?
Yeah, I have tried some just I would say for fun.
Yeah.
I think everybody tried it to answer some questions. And yes, I have already tried, and that raises here some bell in our minds to what I can use this.
Yeah. Have you written emails with a bit of help of
not yet?
Not yet. No?
Just questioning the chats to see what comes from it.
Okay, I've done it. I've sometimes have a hack like, okay, I want this. Now make it nice, and then I can send an impolite email.
You include the message you have already, and then they rephrase it.
Yeah, just in bullet points, and then the models are sometimes a little bit overly nice, like thank you for blah blah blah. And usually I'm not so nice in my emails, but I need to find that sweet spot. Kayo, have you used these chat models or any other models for
definitely,
anything? Yeah.
Again, also for fun, also for work.
Yeah.
So for fun, say music generation, or even maybe if you ask for an opinion. So I have a melody like this. How should I finish? Or something like that.
Whoa! So you're using it like as a music coach type of thing. Yeah. Wow. Cool.
But also for work, like the email thing. Just to have a nicer tone if you're going through a hectic day. Yeah. So, let's make it more human instead of just throw a bullet point of stuff. So yeah.
Okay, interesting. Hey, and can you maybe tell us more about how do we go from an LLM to chat? Like because it's not the same thing. So how do we go from?
Okay. So chat is something that is, let's say, stateful. And we can have, so maybe we can think of LLMs
What do you mean it's stateful?
So that considers a current state and given a past event.
So you mean the chat history? Or
Exactly. So just before we go into this topic, the nitty-gritty of it in simple terms is like, imagine you're typing something in your phone and you have a spell check or a corrector that suggests the next word.
Yeah.
So in essence, that's what the LLM is about, is predicting the next word, but in a powerful level of complexity that, again, like I mentioned before, it gets the gist of language and semantics. So with that in mind...
So for me to understand, so you're saying that the large language model is basically really good at predicting the next word, just like on your phone where you have the three suggestions basically.
But let's say on steroids, because the phone gets maybe the last word or that very message you're typing, but just for the sake of sounding nice, with large language models is the message that you're sending through language is what matters. So it's way more intelligent, way more useful, so to speak.
Yeah.
So in here, the generative part is not only predicting a word, but predicting what to say. So what it outputs to the user.
Word, yeah.
Yeah.
Okay.
Yeah.
And so how do we go then from being able to predict the next word to being able to help me write nicer emails?
Okay. So then that's when it comes the prompting. So whatever you input to a model is called a prompt, and whatever the model spits out, it's called the completion.
Okay.
Or the output. Okay. So then, to make it a nicer email, so that's when we get to what we call prompt engineering.
Mm-hmm.
So with that, we need to write something that is unambiguous enough, concise, so you deliver the message in a clear way to the large language model. So then you can have your email, or in the case of making it stateful in chat conversation, you can have a context on what the chat is about. Or like if I'm an assistant helping you and on some way delivering messages in some tone, right? So then you can define some sort of context, and there's no previous state, because the input is the whole world where the reasoning is going to happen, where the language model is going to do the reasoning. So if you send a message once, and if you send the next message, it won't consider unless you include the past, the history of the past messages. So whenever you have a new message, you need to include all of the previous ones. So you can have what's happening, so then it can answer properly.
So every time we have a chat conversation and that we ask the large language we ask the large language model to give an answer. Basically what we're doing, as you also see on the picture, is sharing the entire conversation history, and that's how we get that next message.
But the sky's the limit. Maybe if you want to forget about stuff in the past, retrieve the last 5, 6, 10, 20 messages, it's just a matter of how you use it. Yeah. But that's up to the software layer and the application of large language models. If you want to have the whole conversation, so be it, included there.
Okay.
Or if you want to have a shorter attention, it's up to us to decide how we template the prompt and how much of history we include there.
Interesting. And what I've done also, I know you know how you can Google yourself, like see that you type in your own name, you see what pops up. You can also like ask these chat models to type in, like, write a biography about myself. I've done that, and then it says that I've studied computer science and that I have got a PhD, and I've got neither of those things. So I think like that's a concern that sometimes people have, is that these models they're not perfect. So can you maybe tell us, like, how should we deal with that? What can we do about those type of limitations?
So if we're famous enough, we may appear in those huge amount of text we use for training, aka the data set to train the model.
Yeah, I'm not famous enough.
So let's consider, there we go. Let's consider we're not famous. We're not celebrities. So maybe we need to stack up more heuristics on what we call here clever prompting. So then we need to retrieve some domain-specific information, be it your bio, your history, or if you just wrote a book, you didn't even publish it, how come the LLM is supposed to guess what is in there? So that's when it comes another level of complexity, because you're giving more capability to the model. So then you are including specific material. So that includes a whole stack of technologies, starting with whatever you want to talk about, for example, your bio. So you need to feed in the material you have about you.
Yep.
So then it needs some sort of ingestion. It needs some sort of, say, segmenting this material, because I won't give a whole chunk, boom, to the model and say, like, yeah, find it.
We cannot expect we'll load in the entire phone book or all of Wikipedia in one go.
Exactly. So we got to do it in a smart way. So when we ingest some material, it's nice to just segment it in parts, just as the books have chapters, for example. So why not segmenting in this fashion?
Yeah.
And index it in the way that the large language model would see it.
Yeah.
So the large language model is something with billions of parameters, numbers. So let's represent that as numbers. So then we can index that in this representation. And whenever we are searching for some specific detail about gens, so we can use semantics itself to do some to search about information by the similarity of what you're asking for. So then from the question you have, you get numbers. From whatever is indexed, you have numbers. So you can use mathematical tooling to get what is the closest to what you're what you're prompting, what you're asking for. And then you can retrieve stuff, and then we go back to clever prompting. We stack it up into the context the model is going to do reasoning. So we include the specific information you want the model to do the reasoning, and then it crafts an answer for you.
Okay, so if I understand you correctly, then what you're saying is, yes, these models, because they just predict the next word, and they're trained on this large public data, it might not be able to create always factual information.
True.
And a way to go around that is to make sure that the facts that you care about are already in the prompt. And the way to do that is to basically use the question that somebody has to find in your search index what are relevant documents, and then to paste those into the prompt to get them there. That's cool. Hey, I see we have a question from the people at home, and that one is about, so what kind of role and form do you consider prompt engineering play in the future?
That's a very good question. The role could be, I think my answer is even going to change because this field is, and even how we organize this field, it's very alive and it changes a lot as we advance in technology. But let's say this is part of maybe for the data science, maybe for the data scientist, because we're dealing with the model right there. So let's say at the moment could be for the data scientist, yeah.
So you're saying data scientists will do some prompt engineering. So do you think other people will also do prompt engineering, or just data scientists?
Well, it extends to it all. Like maybe whomever is coding the infrastructure as well, because it has templating, and we have a very large set of tools, like the heuristics you put on top of the final prompting. So maybe involves a bit of, say, even soft engineering, depending on where or how you're implementing applications. Yeah. But then let's say, okay, let's do like this. For the sake of having the program ready to run, it belongs to software engineers or And when it comes to the gist of it, on how or the quality of the output, the inambiguity, if I can say it that way, then I think it would go towards data scientists.
Okay, so basically what I'm getting also from you is that it's a responsibility of the team that manage the application, and there's multiple people working in there. And then maybe the other side of the question is then also, like, say, so prompt engineering is one way to get, is one part of the total picture, but it's not, is it also everything, or are there maybe things that maybe replace or complement prompt engineering?
What do you mean by replace?
Yeah, so is prompt engineering the only way to get nice results from your model, or are there other ways also to do so?
We can tackle this from many different ways. So one is prompt engineering. Another one is like what we discussed as feeding domain-specific contents, or if we need to tailor the large language model to a very specific way to respond, or how it responds, structured or non-structured way, we can also do some fine-tuning.
Okay, so then when you say how it responds, that's maybe interesting for businesses, because there, I've seen this come from one place where you have, let's say, specific tone of voice.
That can also
hey,
be
we want the
possible.
model to talk back to us in a very upbeat way, or not so much because we are a very serious bank, or we are a very happy-go-lucky web shop. Maybe they want to have a different type of responses.
Yeah, verbosely, concise, empathetic,
Yeah.
skeptical, or let's even say there are even applications where we give more empathetic answers when we deal with humans, for example.
Yeah.
When something goes right to for a human being to benefit from that answer.
But what you mean is that we can configure the model to be, I don't know if it is correct or not, but to be more serious or more fun.
You can definitely change the
Okay.
tone. Yeah.
Mhm.
All right, great. I saw one more question also at home, which was about if we use the standard OpenAI version of a private version for work emails. So maybe, Kayo, do you want to talk about how we do that here at Xebia?
If we use a standard or
Yeah, if we use like the public OpenAI models, or if we use something else for work emails. I think the question is about privacy.
Okay, so yeah, when it comes to privacy, I would say the open version. They can use the data for continuous improvement. So maybe what you're typing right now can belong to a data set for a future version of the model. Whereas when we use the private version when we pay for the service, it wouldn't be part of it.
Yeah.
So when it comes to sensitive information, I think it's best not to just blindly use a very public tool.
Yeah, the public commercial services have some privacy issues, and if you use something from a cloud vendor, open source model, then you have better protection.
Yeah.
All right,
Definitely.
great. Hey, so we talked about prompt. We talked about these models. They are really good at predicting the next word, and that can be useful. You can even make a chat app out of it, basically. But sometimes they say the unfactual thing. You get unfactual returns, like I don't have a PhD. We can help that by making an application like we see on the picture over here, where we can then dynamically put in the right facts, basically, to try to get those facts more out. Are there any other ways that you see that you can basically add more capabilities now that we have these LLMs?
Okay. Short answer, yes.
Okay.
Long answer, well, then you can bring, so as I said before, all the reasoning happens inside that very scope of the prompt. So all the reasoning is going to do only there. LLMs don't have access to internet. It's just a tremendously huge mathematical thing that's going to predict the next word. So what we need to do is we need to break whatever you're asking, break down to smaller tasks, and if I don't have access to it, we need to take some actions. So actionable AI is a thing that can help you with that. And let me just make a very important statement here. There's no thing of AI taking over the world. In this case, when we talk about actionable AI, the LLM just tells you what to do. And whether you're doing or not, it's up to humans to grant that, say, privilege. It's not even a privilege because the LLM is not doing it. But it's just we're just retrieving instructions, the plan to answer a question. We retrieve a plan from the LLM, the large language model. So then, for example, some fact-checking, LLM has the LangChain, which is a library to use large language models. They have a very funny example of there's a random question, I think, who's DiCaprio's girlfriend and what is her age raised to the point something power? That's a very random question. Who asks that? Who wants to know this? But it can answer this question to this level of precision. So with that, we need to break down to smaller tasks. So we have entities in there, and maybe we do change partners in life. So a partner won't be something final to include in the data set and be, so that's it, right? So maybe we need some factual checking, for example, who is his girlfriend? So let's Google search, for example. And then we have a tool. So we break down, find out who this person is, and we can have a tool whenever we need to find out about people. Let's Google search. Okay, so the LLM can match.
How does the LLM then decide to do a Google search?
So then you can offer tools that are, suggest this tool when you have a situation like fact checking. Use this tool whenever you need to do math operations. Do this tool whenever blah.
Okay.
So if the, and before that, we need to break down the question into a plan on what to do. First, I need to know about this.
Do we need
and
to do that, or does the model do that?
The model does that.
Oh, okay.
The model does that. So we have a software layer on that, which is, say here, LangChain, which breaks down into. So we don't ask everything at once. We make separate requests, tinier requests to the large language model. The first one is break down into a plan.
Yeah.
So given the plan, we match every task that we need to accomplish to whatever set of tools we have available.
Okay.
So then fact-checking would match with Google search if we grant availability for this tool. So when it does match, let's Google search, retrieve the information. And let's do a math operation, for example, raise the age of whomever is his girlfriend to the power of blah.
Yeah.
So this is math. And LLMs are not necessarily good at math. They're not supposed to. It's language, right? So whenever you have a math task in front of you, so let's match with a calculator, for example. Let's do the task and let's bring it back. So whenever you accomplish every sort of tasks with the outside world, then you glue it all, bring it back. So the answer, the plan is this, I got this back. The plan is this, I got this back. So the LLM again is gonna do all the reasoning and craft the final answer for you.
All right. Wow. Thanks for that overview, Caio. Now, what I'm really curious about this, so we see like these main levels of the different types of what you can do with it. So just some clever prompting, and from there you can go from LLM already to chat. With that level 2 that you say, you can make sure that it has the right facts available. And with this level 3 that you're now saying, you can even integrate it with other tools to add another capability to an LLM-powered application. So maybe now going then back to Rui, and let's maybe talk about how you see these type of technology helping out for your product, Aria, at ING. Can you maybe tell us something about that?
Yeah, so what definitively we would like to try, because as I explained, so we have a huge pipeline, in this case for the articles, okay? So deep diving a bit on the articles pipeline.
Yeah.
We really have some challenges there, and we would like to experiment LLM approach. First, to make it simpler.
Yeah.
That is the main goal. We would like also to reduce some costs because, well, this is a huge project, and in every component that we can reduce costs, it will be great for us. But the main goal is to improve the accuracy of the tool. So now, as I explained, so we use machine learning models, and well, to improve a machine learning model, we always need some feedback from the users to check, to say if the response is okay or not okay, and then we can improve the learning of the machine. And this is the way we are doing it. So the users are giving us feedback. But we would like to improve the accuracy. So we are still with some false positives and some false negatives, and we would like to experiment to see what is the behavior of this LLM. Maybe, like you said, not in a fun way, but in a serious temperature, because we are speaking about risk management in a bank, so it should be really serious. And so we would like to do this experiment mainly to improve the accuracy of our signals, so the signals that we send to the users, and so what we would like to do is, well, using a sample of the articles that we have, we would like just to send some questions to the tool, to the model. Maybe here we will need to have, like you said, so it needs to have a contest before we start sending questions, right? So this tool needs to know that this is business, this is bank, this is risk. So, and in this part, I don't know what we are going to do, but we need to give some context to the tool. And then we would like to raise the questions that we are now doing step by step in the pipeline. Like, for example, sending an article to the model and ask, this is about fraud, or this is about bankruptcy, this is about human rights. And so this will, I would say, replace the part of the machine learning model saying this article is about the topic A, B, C, D, or whatever it is. We would like also to know if this article, what is the sentiment behind it? It is a positive or it is a negative? And in this case, we would like to know more the negative sentiment, because we need to know which clients could be at a potential risk. Also, we would like to use these models to find entities inside the article. So like I explained before, so now we are using DBpedia, so we have a huge list of names for example, ING or any entity, and then we need to do the mapping to the final entity. So I would like also to try with LLM what is the behavior of finding entities inside the articles, but also understand if it is really a business entity. Like, for example, if the model finds Jaguar, I don't want the animal. I want if it is Jaguar, the entity. And this is also something that we would like to experiment. On top of it, one thing that we would like also to experiment is with different languages. So now we need to translate everything to English, because our machine learning models are using words in English, okay? And as far as I know, but Kai, you can tell me better. As far as I know, so the LLM could be multi-language. So we can have an article in Portuguese or in Spanish or whatever it is, and we can ask the questions in English the same, and we will have the answers in English. And so this is something that we also would like to experiment, instead of translating every article to English. And well, finally, we would like also to try 1 million question that will be fun, will be really useful for us. That is questioning the model. Is this article talking about could be a potential risk on the entities that are inside the article? And well, with all of these questions and answers, we would like to replace some of the steps that we have already in our pipeline to retrieve this information. And of course, we would like to do this in a structured way. Of course, so we would like to raise all of these questions. Maybe Kai also can explain a bit of this, that the output could be in a structured way. So we have structured databases, and we would like to have, I don't know, maybe a JSON file or something more structured that we can use to include in our database, and in that sense we can then do all the queries and search for the entities that are really at a potential risk. But this needs to be, of course, we need to experiment that, we need to compare with the current models that we have already.
So if you allow me to add a comment here. Of course. It's interesting how you can either use language itself in a prompt to ask like the format of the output, and how the structured bias the model can get when you say, give me a JSON. JSON is not language. So the model itself would know already it is about tiny pieces, not JSON with verbose all around. So JSON is something structured, so it already gets the structured bias to deliver an output. So this is very, it can be very useful to detect very precise information, I would say, in a structured way.
Yeah, and what we also would like to do is, one example, in our pipeline, in the current pipeline, let's say that we have an article and we find in a negative way that this is about the entity X, okay? and it is about human rights. So this entity has something wrong about human rights. And we send the signal to the account manager or to the risk manager responsible for this entity. Then the person read the article and decide if it is really a problem or not. But one thing that we cannot do now, and we would like also to experiment with LLM, is to tell to the user why it is about human rights. So trying to collect from the article the exact parts or the piece of text that resonates that this is about human rights in a negative way. And in that way, we can say to the account manager, this article, we believe it is about human rights, and this is the why we believe it is about human rights. And I believe with LLM can retrieve also this kind of information, then we can present to the user.
Yeah, that's great, because of course if you only get the flag like, hey, here are 5 articles saying this article is about that topic, you still have to read the whole article to know what it's about. So if you get a bit of a summary or a highlight, then you can take faster actions.
Exactly.
Great.
Exactly.
Looking at the time also, I think it's really great to hear, let's say, what is the what you're going to do here, what you're going to try out with large language models for this application, which is really big, right? 300,000 articles per day. I want to finish up with maybe some broader examples that what we've seen generative AI being used for in the world, let's say. So maybe Kayo, can you maybe share with us some other applications that we've seen in the world?
Yeah. So let's start with LLM is cool, and there's a lot of stuff you can do with it, but it's also nice to think about a responsible use of it. So let's start with something with some negative examples. Okay. So for example, the first thing you can think about scams. So you have a powerful tool in your hands. So you can benefit from it in a not very cool way. So by scamming people you can craft some phishing emails or something, or even if we go to image, stable diffusion kind of stuff, you can impersonate like image, voice, combined, say video. So this can be dangerous and not responsible at all.
Yeah.
There's also the case of, say, leaking data.
Yeah.
So I won't even need to go further. Leakage is something that there is a responsibility of dealing with the data and addressing these kind of issues. Music, I love music. I mean, it's really cool to work with music, but we have copyrights and we have people, and again, it's not a scam when you impersonate another person for bringing joy, but there is still some people make a living out of their image, and others impersonating the image could make money out of that in a say legal way. So yeah, these are kind of these are cases that we need to say, okay, I have a big power in my hands, so is it the right way to do it? Should we even partner up with that very person that we're representing in an image or in a song, in a voice, rather than just doing it yourself and without thinking about consequences and stuff?
Yeah. So you're saying there's some very straightforward ways in which it can be misused, like these deep fake scams. I don't think anybody would agree that disagree that that's not great. And then there's the second example where leaking data. So I should not put my email text into the public chat services, because then I might leak company data there. Yeah. And then you have the other parts where you're talking about the what do you call it? Like intellectual property rights, basically,
yes,
so that
exactly.
you cannot just copy things over there.
That's a word for it.
Those type of things. All right, great. And then maybe to end up on a positive note, what other joyful or great examples do you see?
On the other hand, again, it's cool, and there's a lot of cool stuff to do. So one of those could be let's say generate something that is now free that is not that is no longer intellectual property and falls
Can you give
in,
an example?
like the Mickey Mouse, we can have, so recently Mickey Mouse was free from copyright protection.
Yeah.
I would say if it fell into public domain. So that, for example, you can benefit from it and generating something that is okay to generate and for whatever purpose. Or, for example, we were talking about changing the tone on the answer. So maybe if we have bad news to deliver, say, in a doctor-patient relationship, you can, and doctors, I believe they do hate that part. So why not throwing a bullet point to the LLM to say, this is the situation, so hey, deliver it in a way that sucks less. Let's put it this way. So in a more empathetic way, rather than the doctor wanting to deliver it all in a very precise way, but maybe in a not so warm way.
All doctors are robots in that they don't like to interact with others. But I can also imagine that if you're just very tired and having to work hard, then maybe it's nice to get some help in being able to craft, to strike the right tone and type of things when you have a tough situation, because they have complex messages to share. Yeah,
true. The LLM won't speak for us, which is also a very important thing to point out. It just makes our productivity higher. So, oh yeah, I should take that tone on when addressing the patient. So I'm brain dead. So yeah, help me out, LLM. So, oh, this is a good idea. Then on top of it, we make it even better and deliver the good news. There's also Slack GPT. Another, this is something we did in Xebia, which is just, we use the private version of a large language model. And instead of opening, so I'm talking to you, say we're using like Slack, and we need to verify something that we don't know. We can even say like, I don't even leave Slack. I go to Slack GPT and say, blah, and it gives me an answer, and then we go back, or we could even have a chat group, and I just join the group, and I can even invoke Slack GPT to the very big conversation, to TLDR. So Slack GPT, what is it about? And then it gives something. So yeah, many cool ways to use it.
All right. Hey, I'm looking at the time. It's almost 11, so we should wrap up, and that's great. I want to thank you here at the table, Rui, Caio, for helping everybody and me understand more about what is possible. Thanks for the people at home, specifically the people especially who ask questions, because it was great to try to include them here in the conversation. If you want to know more, there's a link where you can see more about how Xebia can help you with Gen AI, and I hope to see you in the future. Thanks.
Thank you.
Thank you.